Good morning, students. So today let us continue with the next session, that is today is going to be the 34th session under states of matter. The topic is going to be kinetic theory of gases. Under this we are going to study critical phenomena, critical constants and their calculation from Vanderwaals equation. In today's class we are going to discuss what is critical phenomena, the critical constants and their calculation from Vanderwaals equation. Critical phenomena and critical constants. The liquefaction of a gas is described by critical temperature, critical pressure and critical volume. A gas can be liquefied and the conditions here are going to be described by the critical temperature, critical pressure and critical volume. These are going to be the gas molecules, and these gas molecules can be condensed into a liquid. By with the increase in pressure or with decrease in temperature. This is the low pressure. With increase in pressure, the gas molecules come close by, and at one temperature it gets converted into liquid. That we are going to study under critical pressure. Likewise, at higher temperature the gas molecules are far away, but as the temperature is decreased, the molecules come close by and ultimately be converted into a liquid at a given temperature. This is actually what we are going to do in study in today's class, that is critical temperature, critical pressure and critical volume. Coming to these three critical constants, first let us go ahead with critical temperature. The temperature above which a gas cannot be liquefied, howsoever high pressure is applied, is called critical temperature. That is, the temperature above which a gas cannot be liquefied, however high pressure is applied, is called critical temperature. For example, the critical temperature of carbon dioxide is 31.1 degrees Celsius. So, above this temperature, however high pressure I apply, the gas cannot be converted into a liquid. Now, coming to critical pressure. Critical pressure, it is the minimum pressure required to liquefy a gas at its critical temperature is called critical pressure. That is, the minimum pressure which is required to liquefy a gas at its critical temperature is called critical pressure. For example, the critical temperature of carbon dioxide is 31.1 degrees Celsius. That is, at this temperature, what minimum pressure is required to condense a gas into the liquid carbon dioxide will be called critical pressure. And the pressure required is going to be 72.9 atmospheric pressure. That is, when I apply 72.9 atmospheric pressure and 31.1 degrees Celsius, the gas gets converted into a liquid. So this pressure is the minimum pressure required to liquefy the gas at its critical temperature is called as critical pressure. Coming to critical volume. The volume occupied by 1 mole of a gas at critical temperature and critical pressure is called critical volume. The volume occupied by 1 mole of a gas at critical temperature and critical pressure is called critical volume. For example, volume occupied by 1 mole of carbon dioxide at 31.1 degrees Celsius, which is the critical temperature of carbon dioxide, and 72.9 atmospheric pressure, which is the critical pressure of carbon dioxide, is found to be 95.65 ml per mole. So this volume is called as critical volume. The next concept is going to be calculation of critical constants from Vanderwaals equation. We know the Vanderwaals equation is going to be given by the expression P plus A by V square into V minus B is equal to RT. This is the Vanderwaals equation for 1 mole. When I simplify this equation, it comes to be PV minus PB plus A by V minus AB by V square will be equal to RT. Next, what am I going to do is I am going to multiply the above equation throughout by V square. When I multiply the above equation throughout by V square, I will be getting it as P V cube minus PB V square plus AV minus AB will be equal to RT V square. Next, I am going to divide this equation by P. When I divide this equation by P, I will be getting the expression V cube minus V square plus AV by P minus AB by P will be equal to RT V square by P. Rearranging the equation in the decreasing powers of V. I am next going to rearrange the expression in the decreasing powers of V to get the following expression, that is V cube minus V square plus B plus RT by P plus AV by P minus AB by P is equal to 0. This equation is a cubic equation in V. On solving this equation, we will get 3 solutions. This is going to be a cubic equation in V. On solving this equation, we will get 3 solutions. At critical point, all these 3 solutions of V are equal to critical volume. The pressure and temperature becomes critical pressure and critical temperature. That is at the critical point. At critical point, this volume will be equal to Vc. So, when I just going to rearrange it and take the cube of it, it will be V minus Vc cube will be equal to 0. I am now going to expand this equation. V minus Vc cube. That is, this expression will be V cube minus 3Vc V square plus 3Vc square V minus Vc cube. This is going to be on expanding this expression V minus Vc cube. Expanding this, we are going to get the expression V cube minus 3Vc square plus 3Vc square V minus Vc cube. Further, the Vanderwaals equation may be further written as, this is the case where I am going to write down the Vanderwaals equation. At critical point, the P becomes PC, T becomes TC. So, substituting P and T as PC by TC, the second equation 2 is going to be rewritten as V cube minus V square plus VRTC by PC plus AB by PC minus AB by PC is equal to 0. At the critical point, equation 1 and 3 must be identical, equating the coefficients of the terms of similar powers of V. I am going to equate the coefficients of the terms which are having similar powers of V. That is, Vc, 3Vc will be equal to B plus RTC by PC and 3Vc square will be equal to PA by PC. I am going to equate the coefficients. That is, this is going to be for V square. For V square, this is going to be the coefficient. So, I am going to equate the coefficients over here. That is, for the equations, I am going to equate it here. When I am going to equate the coefficients, that is, 3Vc will be equal to B plus RTC by PC. 3Vc is going to be for V square. So, this one 3 for V square. So, this is going to be 3, this plus is not there. So, it is going to be for V square. It will be 3Vc will be equal to B plus RTC. It is going to be B plus RTC by PC. Then 3Vc square will be equal to A by PC. 3Vc cube will be equal to AB by PC. Dividing equation 6 by 5. I will be getting the expression on after simplification. Vc will be equal to 3b. Substituting the value of Vc in equation 5, we get 3 into 3b square will be equal to a by pc, and this will be equal to pc plus a by 2b square. Substituting the value of pc and bc in equation 4, we are going to get 3 into 3b will be equal to b plus rtc. Further simplification, I will be getting tc will be equal to 8a by 27 rb. So this is all about in today's class. So we have studied what are the critical temperature, what is critical pressure, what is critical volume, and the relation between the critical constants and Vanderwaals constants. Okay, thank you.